Alright, so we're going to begin our review of solving equations in preparation for solving more complex trig equations, okay? So we're first going to look at quadratic equations that do not involve trig, alright? So if you recall, there were a few different ways that we could solve quadratic equations, right? We could use this thing called the zero product property, right? Which said that if multiple factors multiplied out to zero, then we would know that at least one of those factors was equal to zero. Okay, so we would generally want to get things in that form, right? We want to get things to look like a times b equals zero, because then we would know that at least one of a or b was zero, right? But the idea is, how did you get them in that form first? You would first often have to factor, right? So you'd have to factor, and then each factor would be set equal to zero, right? Now, the problem that arose apparently sometimes was that things wouldn't factor, right? So when things didn't factor, you'd have to use the quadratic formula, okay? So quadratic formula says that once you get an equation in this form, ax squared plus bx plus c equals 0, if it's not factorable, the solutions would be given by this formula here, right? And notice the plus or minus there in the formula, because generally when you have quadratic equations, they're going to end up giving you two solutions, right? In general, not always, but usually, okay? So let's take a look at some of these. So the first one we can see is actually quite simple. Number one, because it's already set up in this form, a times b equals 0, right? So you look at this and you say, all right, well, this is a, this is b, they're being multiplied, and they give you 0. So this fits exactly into the zero product property form. So what do? We just take each individual factor and set each of them equal to 0, right? And we just keep these separated. So in this case, we would end up with either x equals 1, or here we would subtract square root of 2 and divide by 2. So we'd end up with negative square root of 2 over 2, right? So that was very straightforward because of the fact that it was already in the a times b equals 0 form. We didn't even need to factor, okay? Now, 2, yes, it's equal to 0. However, it's not in this a times b equals 0 form. So what we need to do in one like 2 is we need to say, all right, well, I need to factor this so I can write it in the form a times b equals 0. So how do I do that in this case? Well, this one is fairly straightforward. It's just one of these GCF problems, right? Greatest common factor. What you do is you look for the biggest expression that will divide evenly into 3x squared and 18x. So, all right, so we have 3 and 18. So the biggest number that will go into both of those is 3. And we have an x squared and an x, so the highest power of x that will go into both x and x squared is x. So the GCF is 3x, and that actually becomes our first factor, right? So that's our first factor. And then the second factor is going to be what's left after you divide 3x out, right? So if I have 3x squared divided by 3x, well, the 3's cancel, one of the x's cancels, and I'm left with x. And then here, 18x divided by 3x, well, the x's cancel, and then 18 divided by 3 is 6. So I end up with x plus 6 equals 0. So in this case, now I'm in this a times b equals 0 form. So now I just set 3x equal to 0, x plus 6 equals 0, and I get my two separate solutions, right? So here I divide by 3, so I get 0. Here I subtract 6, so I get x equals negative 6. All right? So again, pretty straightforward. Now number 3, the problem with that is it's not equal to 0, right? Now the mistake a lot of people will make here is they'll say, oh, okay, I can divide out an x. No, you don't do this, because if you do this, what ends up happening is you're losing one of your solutions, right? Because the idea is, well, what if x is 0? Then I'm dividing by 0, which is illegal, right? So you can't do that. So what you must do here is get it in that form where it's equal to 0. So how do you do that? You move the x to the other side, right? So you subtract x, so you end up with x squared minus x equals 0. And now it's just a GCF problem like number 2 was, right? X will go into both of those. Then you're left with x minus 1. And now again, x equals 0, or x minus 1 equals 0. So you end up with either 0 or 1, right? I guess we should kind of be highlighting these solutions along the way, right? Those were our solutions there, okay? All right, so now that we get into number 4 and 5, now we're in ones that are no longer GCF problems, but they're actually, well, number 4 isn't anyway. Number 5 looks like it's GCF, but number 4 is actually one of these ax squared plus bx plus c equals 0 problems, right? So there were a couple of different ways that you could do these. You could use what we call the AC method, or you could basically just guess and check. Because the idea is that if these things are going to factor, they're going to factor into two binomials, right, that look like that. So you remember how you would FOIL, right? You'd multiply the first two first. That's the f. So the idea is what's going to multiply to give you 2x squared? That's going to be the f. So these two things here have to multiply to give you 2x squared. And there's really only one way that can happen, and that's if you have a 2x and an x, right? And then this, you have a plus 3. So the only way you're going to get that, a positive 3 by multiplying, right, that's going to be the L, is if you had a 1 times a 3. Now the problem is the middle here is negative 7. So the only way you're going to get something to multiply to a positive but add to a negative is if they're both negatives. So you really need a negative 1 and a negative 3. That's the only possible thing that could work here. Or it could be reversed, and it would be a negative 3 there and a negative 1 there. So what you're really doing is you're just doing all possible combinations and then basically checking to see which one works, right? So which one ends up working if I do my FOIL? Well, I already know my F and my L are going to work because that's what I just did. So now you do the O and the I, right, to check. So the O in FOIL would be 2x times negative 3, which is negative 6x. And then the I in FOIL would be negative 1 times x, which is negative x. So this and this gives you negative 7x. So my initial choice of negative 1 and negative 3 are what works, right? So the negative 3 first and the negative 1 second wouldn't have worked. So this is what works. So now I have it in the form a times b equals 0. So again, just set them each equal to 0. And I get my solutions, right? Add 1, divide by 2. So here 1/2, and add 3. So here x equals 3. So there's my two solutions, x equals 1/2 and x equals 3. So continuing with these quadratic equations, we look at number 5 here. And number 5 actually looks a little bit strange probably to us because it contains two variables. But as you'll see later with trig equations, a lot of times you'll have trig equations that might have two different trig functions in them. So this will kind of replicate that before we actually do any of the trig equations. But this is not really as tricky as it seems, because you look at this 5xy plus 4y equals 0 and you say, all right, well, look, both these terms have a y. So we can actually pull that y out as a GCF. Right? And again, remember when we did this before, the GCF was our first factor. So now when you pull out a y, well, what's left when you take a y out of each term? Well, you're left with a 5x in the first term and a 4 in the second term. And now this multiplies to 0, and now you have your zero product property again, right? So in this equation now, all right, I set the first factor equal to 0. I get y equals 0, so that's done. And then the second factor equal to 0. 5x plus 4 equals 0. So x would equal, subtract 4 divided by 5, negative 4/5. So there's my two my two solutions, right? Y equals 0, x equal negative 4/5. So not as tricky as it looked, right? Not at all. All right, so now if we go back to this other side here, number 6 now actually is a little strange because of the fact that you might look at this and say, hey, this is easy, right? I just say, it's already factored, so I have the first factor equals 2 and the second factor equals 2, right? But no. And the reason it's no is because if you look at your property up top there, it was called the zero product property. This is a 2. So setting each of these factors equal to 2 will not work, right? That property only applies when you're multiplying out to a 0. So this one is actually probably the most complicated of all of them. Not most difficult, but most work involved. Because for this one, I actually have to FOIL first, then move that 2 back over, and then try to factor again, right? So this is a little bit of an annoying one, right? So I would FOIL this, do this quickly because there's no space, right? I would end up with x squared plus 3x plus 2x, which is plus 5x, and then 2 times 3 is 6 equals 2. And now I would move the 2 over, and I would have x squared plus 5x plus 4 equals 0. And then what you would do with this one is you'd say, all right, this is one that since it's just ax squared plus bx plus c, we don't really have to guess and check. We can really just think, all right, well, what multiplies to a 4 and adds to a 5? So what numbers are going to multiply to 4 and add to 5? That's easy, right? Multiply to 4 and add to 5. It's going to be 4 times 1 equals 4, and 4 plus 1 equals 5. Right? So in the case of these x squared plus bx plus c ones, the minute we find that magical combination, right, that magical pair, we just know what our factored form is going to be, right? And our factored form is going to be x plus that first number we found times x plus that second number we found. So x plus 4 times x plus 1 equals 0. And then again, what we did before, set these each equal to 0. So we'd end up with x equals negative 4, x equals negative 1. And there's our solutions, right? So that wasn't terrible. And then with 7, what you do is you get into this whole idea of the square root property, right? Because you might look at x squared minus 3 equals 0, and you might say, hey, that's not going to factor. I mean, technically it would factor. It's a difference of squares, but we won't even look at it that way. We'll look at this like we want to get it into this square root property form. Oh, they don't give you the square root property here. Interesting. But that's what we want to do. Since there's no x term in this case, right, there's just x squared, we can isolate this x squared. So we can add 3. So you'd have x squared equals 3. And now if we want to solve for x, if we just have x squared, well, it's just the whole idea of solving equations, right? Inverse. What's the inverse of squaring? Square root. So we take the square root of both sides. Now the only thing here that you got to be aware of is when you're solving an equation and you take the square root, you must take the positive or negative square root. Right? Just keep that in mind. When you take a square root in solving an equation, you must do the positive or negative square root. Okay? So in this case, the solutions are the positive square root of 3 or the negative square root of 3. All right, so that was your square root property.